Hi, and welcome back to Allen High School's discussion of reactions at the pre-AP chemistry level. What we're looking at now is our final video on how to recognize and predict together. So we're merging the classification with the prediction. And what you want to do when you're doing this is start with writing your reactants. So I have strontium nitrate, and that's a solution, so we put aqueous, is added to a solution of sodium sulfate. Now, to classify it, we can rule out decomposition because it's got two reactants. We can rule out synthesis because this is just too complicated of a synthesis. We wouldn't ask you to do that, plus it's two solutions that are aqueous. The only ones we're asking you to predict of synthesis would be element plus element. It could be double or single replacement because we have two reactants, but I can rule out single replacement because both of the reactants are compounds. So that leaves double replacement. And double replacement are never redox. And if I alternated cations with anions, you might want to put your charges on top to help you make sure you do the correct replacement. We don't want anions with anions. All group 1s are soluble without any exception. That means that the formation of strontium sulfate must have been our driving force, and this is a precipitation reaction. And then lastly, before you walk away, because I do this all the time, I forget to balance. So don't do what I do. Don't forget to balance, okay? The next one, I have aluminum. We know that's a solid because all metals are solid with the exception of mercury, and oxygen gas. So I have two elements, and I know if I have two elements, that means I have a synthesis reaction. And aluminum wants to become aluminum plus 3. Oxygen wants to become oxide. And so that gives me aluminum oxide formed. Ionic compounds are solid. There's no water present to dissolve that. Now, the original aluminum was 0, and it became less negative. The original oxygen was 0. It became more negative. And so we know we have a redox reaction. Okay, cyclobutane is burned. For one, we have a hydrocarbon, C4H8. It says it's a gas, and it's burned. So we supply the oxygen gas. We're going to do a complete combustion, and combustions are all redox. And we have CO2 gas plus H2O gas. And, oh, look what I did. I forgot to balance the previous one. So let's balance both of these at once. I need a 2 and a 3 here. That balances my oxygens, which means I need a 4 on the aluminum. All right, I have 4 carbons, so 4 carbons, 8 hydrogens. So I need a 4 there. That gives me 8 oxygens and 4 oxygens, which is 12. So I need a 6 there. And then that is balanced. Okay, let's go on to our others. Just a few more so you get a sense of what it's like to predict and have to do kind of the whole shebang. So I'm having you watch this in preparation for the test. Water, H2O, is exposed to electricity. So if you want to put electricity here, and the problem doesn't tell us, but that would happen with liquid water, that would be great. I have only one reactant, so this has to be a decomposition. The only decompositions that you have to do is decomposing to the elements. So that means hydrogen gas and oxygen gas, right? And I need to balance that. I need a 2 here, and I need a 2 there, and that's balanced. Now, these oxidation numbers are 0, and over here it's -2 plus 1, but the point is you have things in a compound going to pure elements which have an oxidation number of 0. That makes it a redox reaction. All right, my next one, lithium, solid. It says piece of, that should be a hint, plus metals or solids except for mercury. And sulfuric acid. Okay. Now, the lithium wants to become lithium plus 1. It's lithium 0 right now. It wants to become plus 1, so we know we're dealing with a redox. We know we're dealing with a single replacement because I have an element plus a compound. So the lithium is going to replace the H plus in the acid. So I'll get lithium sulfate. All group 1s are soluble without exception, plus hydrogen gas. Okay, and I need to balance that. And I think that's balanced. Okay, so that is our single replacement. Acetic acid, HC2H3O2, aqueous. So I have an acid, a base, a hydroxide, sodium hydroxide. So I've got two reactants. They're both compounds, right? Can't be a synthesis because they're not two elements. So the only synthesis you have to predict is element plus element. So this is a double replacement. Since it's an acid plus a base, I also know that it's a neutralization. Neutralization, I can spell and talk at the same time, not. Okay, double replacements are not redox. So the H plus of the acid is going to go with the OH minus to make water. And then that's a liquid. That's my driving force. And then I get sodium acetate. All group 1s salts are soluble without exception. So neutralization is an acid plus a base making a salt plus water. All right. I suppose I should balance this puppy. That is balanced. Good. All right. Let's go on. Just a few more of these and we will be done for this unit. All right, chlorine gas. So Cl2 gas. I've got an element plus a compound and it says piece of. So I've got calcium iodide solid. Element plus a compound has to be a single replacement. All single replacement are redox because we're going to have an element that has an oxidation number 0 going into a compound. Now the calcium's plus 2, the iodide's minus 1. Chlorine wants to become chloride. All right, so it's going to go with the calcium. If you don't write those charges, you're very likely to get these wrong. That leaves iodine all by itself as a solid. Okay, honestly, iodine tends to vaporize pretty quickly, sublimate actually very quickly. Okay, and that is balanced, so I'm done with that one. Methyl alcohol, also called methanol, is combusted. That's a liquid. The problem doesn't tell you that. It's not expected you know that. We should have said that for you. In the test we will. Oxygen gas, combusted means combined with oxygen. I'm going to get CO2 gas plus H2O gas. It's a combustion. All combustions are redox. And now our only task at this point is to balance this puppy. So 1 carbon, 1 carbon, 4 hydrogen, so I needed 2 here. That gives me 2 plus 2, that gives me 4 oxygens. Now, here's where you're going to go wrong. You might put a 2 in front of here, but don't forget, I have that oxygen there. And so I've got 1 oxygen there. That leaves O2 having to provide 3. We're back to that even-odd problem. So let's go back and double our other coefficients. Whenever you have that even-odd problem, double your coefficients and then recount your oxygens. Whoops, should be an arrow. Sorry about that. 2 CO2 gas. Now I'm going to put a 4 in front of the water. Okay, now I've got 4 plus 4 gives me 8 oxygens, but notice I have 2 oxygens here. That means this has to give me 6 So I'm going to put a 3 in front. Okay, good luck on your test, kiddos. This is signing off.